Good morning, statisticians and mathematicians. We've made it to week two. We're going to do lots of equations, but I'm going to show you how to do them all by hand. And I'll let you know that StatCrunch can do it by hand as well as Excel. I believe I used StatCrunch the last set of videos, so I'm going to use Excel for this video. I've been switching back and forth just so who's ever more comfortable with what. But we're doing central tendencies. So I'm just going to give you some basic information before we jump into it. But central tendencies just means the measures of the middle. That's not like variation, which is like the measures of the spread. We just want to know the middlemost stuff. So I'm going to give you some basic background about it first, and then I'm going to go through some problems with you. So I'm sharing my screen, and first thing I'm going to do is go to this notebook. We're up to here, central tendencies. So the main ones you're going to see are mean, median, and mode. Now, all of these have ideas. They all sound really similar. I'm going to close this so we have it. But mean is just basically the average. And I messed it up a little bit on the last one because everybody makes mistakes. So I just do this symbol. This symbol is sigma, which means you add them all up. Then we divide it by the n. So sigma means to add them all. And then the n just means the total number of cases. Now, median is like the middle. This was used all the time when ships were trying to find their way. Think about the prime meridian for the median. And to figure it out, they had to figure out the middlemost route to make sure that the ships would find their way. And that's where this term comes from, the middlemost for median. And to do this, to find the median is just n plus 1, and then we cut it in half. That will always give you the middle term. Then you have to find that middle term. Finally, we have mode. Mode stands for modus. Modus was actually from the Peloponnesian War. It helped the Greeks win that war. They actually had to go around all of their structures, all their defense structures, and count the number of bricks to the top of the walls. And they used the one that was the modus, or the most, to figure out exactly how many bricks were there so they could create their ladders. And they ended up winning. So Thucydides won the Peloponnesian War because of this idea called the mode, which we think about as the most. And then this is, sometimes you could have multiple modes. It could be bimodal. Like if we have two modes, it's bimodal. Anything more than three, they call it polymodal. But you just, when you're putting it in and you're trying to look for stuff, just see if you have a mode. Now, if you use Excel for your modes, you just want to do mode dot multiple. And if it gives you something called NA, it means it doesn't exist, there isn't. Or it could give you multiple modes. So I would do that, equals mode dot multiple. For the median, you just do equal median, and it does it for you. Isn't that nice? If you do equal average, it gives you the mean. So we'll look at the textbook, but this is just the measures of central tendencies, or the measures of center, wherever they want to call it. But these are the three big ones. Let's see what the book has in store for us. So I'm going to go to the book, and I'm going to click Pearson eText. And let's see what chapter 3.1 has in store for us. If there's anything else that's new, I'll throw it in. If not, guess what? We're just going to go right to the questions. So here's chapter 3, measures of center. I call it central tendency. But let's see what we got. So a measure of center is a value at the center of the data set. Cool. We got the mean, which many people call the average. The word average is also, but sometimes they're used for other measures of center. Okay, that's cool. So they give you the mean, adding all the values by dividing by the number. And we got properties of the means. Sample means draw from the last, the mean of the data is value. A disadvantage of the mean, that one outlier. Okay, so this happens a lot, that an outlier can like pull the mean in one direction. So if it pulls it in one direction, If it pulls this thing in one direction, then we can like mess with it and really figure out what's going on. So let's get there. So what does that mean? So if I have like a bunch of data points and we have an outlier, but you could also throw out outliers in your data set if you want. I'll show you how to do that with box plots. Of course, we can exclude them. Can shift the mean. So you have a choice. You can throw them out. It's not really gonna, it'll mess with some other things, but a good thing about it, it uses every data point. The mean is going to use every data point. All right. A statistic is resistance to the presence of extreme outliers. If it doesn't cause it to change very much, that makes sense. Here's our formula. Oh, they put a little x there. I'll put an x there too. So this means sigma. You add up all the x's and then you divide by the number of values. Okay, so here we go. Some more stuff for symbols because symbols are really important. We've got this guy and this guy for mean. And these are basically, this changes. It changes for different formulas. But basically, when we have a sample, we use the X bar. And if we have the total population, use this one. And we call this mu. We call it mu. All right. The formula is the same for the mean, but when we do stuff like standard deviation, you'll see that there's a big difference between population and sample. But for the mean, it's not. And more notation. See the formulas, they don't change. Okay, the other one. For sample, it's the baby N. This is the total participants. And then we've got the big N for total participants. And this is just because of population and sample. I like that they're giving you the notations here. That's part of the book so far. All right, find the mean. I am not too worried about that. Add them all up, divide by how many you got. All right, now median, did I give you any where they come from? That's a shame. So none of them show you where they come from. I'll try to tell you where everything comes from. The first time they were using mean was for when they were giving out, trying to give out, it was in India, I'm pretty sure, and they were trying to give out different types of inheritances, and that's where they first came up with this mean, but to try to make sure people weren't slighted. But median, we know it's from the ships figuring out this. So the original data, so we arrange it in order and we find the middlemost piece. The median does not change by, so extreme values don't change the median, which is great. So outliers don't really mess with this too much. So median is not hurt by outliers. By hurt, I just mean it's not going to be affected as much. It's more resistant to them. But it doesn't use every data value. It just uses one number. All right, if it's odd, we can get the exact middle. If it's even, we have to compute the mean of the two middlemost points. So what does that mean? So if my data is 3, 7, and 11, the middle number is obviously 7. Or we can use the formula m plus 1 divided by 2. I have 1, 2, 3 terms. 3 plus 1 divided by 2. So 4 divided by 2 is 2. So the middle value is the second term. Ta-da! 7. Now let's say we have 3, 4, 8, 11. All right, we have an even number. So if I do the mean, so n plus 1 divided by 2, 4 plus 1 divided by 2, 5 divided by 2 is 2.5. This means the median falls right in between. So the average, 4 plus 8 is 12. So what's 12 divided by 2? 6. So halfway in between is a 6. This is what they mean by it. To get the median. And finally, mode. the mode we can get with categorical can be found with qualitative data. So we can find this with words. We can use mode with just the words, which is really nice. The mode is the number that occurs the most times or with the greatest frequency. You could have no mode, one mode, or multiple modes. Yeah, that's pretty much said. Bimodal, more than two is multi-bimodal. Nice. So it basically said everything I said, except for where it comes from, which is always kind of sad. Which one appears the most? We got 230s, 335s, 250s. There's one mode here at 35. Cool. Now we got another one. Nice. So we got this mid-range, the thing that we found before. Now, the mid-range is the center of the data that's halfway between the maximum and the minimum values. It is found by adding the max and the min and dividing by 2, which is fine. So we add the biggest to smallest, and we cut it in half. All right, for rounding. For the mean, median, and mid-range, carry one or more decimal place than is present in the original set of data. Okay, cool. For the mode, we cannot round because it will change it. So we always want just one more decimal point than what we have. Okay, cool. So hopefully that was good. I think we're ready. I definitely think we're ready to do them. All right, and now we've got mean from a frequency distribution. Part 2 is beyond the basics. Let's check it out. So here we first multiply each frequency and midpoint and class midpoint, and then add the products. That's interesting. Okay. And then we add the products together. Okay. And then we do the sum of the frequencies and we divide it by that. So that's like kind of like the grand mean, which is really cool. So we got another formula for it. And then we have a weighted mean. Okay, so I'm going to show you how to do these two because these weren't on there. I didn't know these were going to be in here, but we might as well. These are how to do them on Excel and stuff. Okay, so let's do these other two equations. It says beyond it, but any formula or anything in here, I'm always going to show you what to do. So here's the first one. We got a frequency distribution. So if we made our frequency distribution, to find our, this is, remember that sample mean, it's the summation of f times x, and we're dividing it by the summation of the frequency. So we have to do the frequency times each term, and then we've got to add them up. So that's what this means. So it's literally the frequency value times the x value times the midpoint. Okay, so we're timesing it by the midpoint. And we have to divide it by what? The sum of the frequencies. Divide by sum of frequencies. So let's check it out. Okay, so if we have this data set, which is already broken down, and we have these frequencies, the first thing you want to do is add up how many you have, which is 50. Okay, so we add up all of the frequencies to get 50. Now, how do we get the midpoint again? Well, the midpoint, remember, oh, sorry about that. The midpoint, remember, it's going to be the minimum. Sorry, I want to do it this way. So it's going to be the maximum minus the minimum, and we're going to divide that by 2. This is going to give us our midpoint. Notice why the first one's 14 minus 0 divided by 2. That gives us what? 7. How'd they get the second one? 29 minus 15 divided by 2 is, ready? Or did they add them? I think it's adding. Yeah, it is adding. All right, so to get that midpoint, we're adding them. We're basically finding the average of them. So it's your max plus your minimum, and we cut that in half. So 29 plus 15, and we're going to cut it in half. Basically just finding the average of the frequency, and that's how you get 22 there. Nice. Let's do one more. 30 plus 44. We're going to cut that in half. So we know that's 30 plus 44 is 77, which is, sorry, 30 plus 4 is 74. Cut that in half. We're going to get 37. So these are giving you the midpoints. Now we basically were multiplying them all together to get these values. And the last step is we take those values and you divide it by the frequency. This is going to give you an average, or basically it's going to give you a mean of the frequency table itself, which is a pretty interesting value. Now, why do we have all these values for middle? Like, as you can see, some of these are more resistant, right? Like mean gets messed up by outliers sometimes. Median has a better chance of avoiding outliers. Mode gives you the most, but sometimes it's not the best. We always just want one value to represent that center. And that's why we have so many choices like mean, median, and mode. This is just another choice. This mean of the frequency, your frequency mean, or your frequency distribution, that mean is just basically you're like, okay, I have the categories I really like. I want the mean from those categories. I feel like this is going to give me a better sense of the values by using one number, not from the original data, but from this table that I built out of the data, what it means. Now, if you want to even get more specific, it's when you use something called a weighted mean. This is even more specific, and you're going to give everything a specific weight to get a better sense of your data. Let's say you just really like these ranges and you want a mean from those ranges. That's when you use the frequency table. But the weighted mean, again, we're using a sample here. The summation, you add them all up. It's the weights times each term. Then we're going to divide that by the summation of the weights themselves. Now, what can the weights be? A good example is a grade point average. Like your GPA will change if you take harder courses, right? Like, so sometimes if you take like all, like in high school, like all advanced placement courses instead of like regular courses, those should have more weight. How does that work in a mean sense? So basically, we can use the weights themselves to change this into a weighted average because we're going to give some more. So let's look at the example. So we get 3 credits for A, the final grades along with the number of credits for each course. This one had 3 credits, that one had 4 credits. So basically, you should get more points for this A because it was worth more. It was worth more credits. That's why. And this F only gives you, it was for 1 credit course. So the grading system is science and it follows that. So we get to compute her grades and just really see how it works. So we will add the weights times each of its values. So use the number of credits as weights. And she got an a B, and a C, and an F. So we know that those get corresponding to the points. So she got an A, which was 4. So that's why the first one, and her first one was a 3 credit course. That's why the first one's going to be 3 times 4. The second one was an A, but it was a 4 credit course. The third one was a B, but it was a 3 credit course. The last one, even though she got an F, this was a 1 credit course, so it shouldn't hurt her average as much as you might think. Just giving myself a little bit more room. So that's how they got those numbers on the top. Now remember, this summation of the weights, we just have to add the weights themselves. So what are our weights? What are the weights that we're using? Well, the weights are the first number. So it's the 3, the 4, the 3, and the 1. So that's what we have to add. 3 plus 4 plus 3 plus 3 plus 1. Those are all of our weights. And we get our final average at 3.07. This is your weighted mean. Your weighted mean. Okay, so And that was a lot of information. I think it's time we just do some of the problems. I'll do the first big chunk of them like I usually do. We use Excel. Why? Because it'll happen real fast. We won't actually have to do the math by hands, especially if they're kind of harder. And then if you for the next video, I'll use for the standard deviation ones, I'm gonna use StatCrunch. So I'll use them both for like I'll keep trying to switch off unless people email me that they really like Excel or they really like StatCrunch. Okay, so I gotta go back and we're gonna go to chapter 3, basic skills and concepts. Here we go. So the first ones we have to do are 5, 6, and 10. Critical thinking, I like it. So we're starting with number 5 and we're moving through a bunch of these. So 5, 6, and 10. So number 5. Super Bowl jerseys listed below are, well, let's read the directions. Watch out for these little buggers. Okay, each of these exercises involves some feature that is tricky. Find the mean, find the mean, the median, the mode, the mid-range, and then answer the questions. Listed below are the numbers of 11 offensive players for the New England Patriot who won the Super Bowl. Find the mean and the median. What are the results? Tell us. It says just 2, but we'll get them all. So the first one, if I wanted the mean, I'm going to add up, and this is the sample because I'm sure it's not every player. Yeah, because it's just on the starting roster. So it's X all over N. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there's an 11 on the bottom. We just got to add the top. So we know it's 12 plus 26 plus 46 plus 15 plus 11 plus 87 plus 77 plus 62 plus 60 plus 69 plus 61. So it's 526. Then all we have to do is divide this by 11. And we have 47.81. Remember, it's always supposed to be 1 decimal point, so that's 47.8. So that is our average or our mean. Now let's get the median. We have to put this in order. So let's put them in order. So that means it's 12, 20, sorry, I already lied. So it's 11, 12, 15, 26, 11, 12, 15, 26, 46, 60, 61, 62, 11, 12, 15, 26, 46, 60, 61, 62, 69, 77, 87. So you have to order it. This is why Excel helps a lot because it'll do all the stuff for you. The next one I'll use the computer for. So to get the middle for the median, I'm going to do n plus 1 divided by 2. So that is going to be, there's 11 plus 1 divided by 2. What's 12 divided by 2? It's going to be the 6th term. 1, 2, 3, 4, 5, 6. So this is 60. Which one looks better? We're basically between 11 and 87. Which one do we like better? Which one do we think represents it more? Honestly, it's up to you. I think the mean is better, but let's keep looking. Let's also find the mode, the mid-range. All right, so let's find the mode in the mid-range too, even though it didn't ask for that. So the mode is the number that appears the most, but in this case, it's not applicable. We do not have one. There's no number that appears twice because you can't have 2 players on a team. And the mid-range going to be the minimum plus the max cut in half. So that is 87 plus 11. Oh, well, I wrote it backwards. So 11 plus 87 divided by 2. So you get confused, you let a calculator help you out. So it's just going to be 11 plus 87, which is 98. And we cut 98 in half, and we're going to get 49. Now, I don't know which one you like the best. I actually think that the average, I like this one because we're using everyone. I don't think we really have any outliers. I would use the average for me, but honestly, it depends. Look how close the mean is to the mid-range. I think that just shows that it's a better measure of central tendency. The fact that there's no mode means we can't even use it. So let's say this was too hard for you. Guess what? That's why we have a program to do all of this math for us. So we don't even have to think if we don't want to think. I hope that's nice. So we've got 11, 12, 15, 26, 46, 60, 61, 62, 69, 77, and 87. We can literally just do equals average and highlight them, and we're done. Boom. 47.8. And I'm just going to put the word mean here so I don't mess it up. And then I'm going to put median. Guess what? Equals median. I'm going to highlight them all. Boom. 60. That's what we got for the median. And let's do the mode. Now this should be an NA because there is none. Mode. Just make sure you put dot multiple for this. So when we highlight it, you'll see that it should say NA for no mode because we don't have one. Now mid-range, they don't have one, right? So there's nothing for mid-range here on Excel, but guess what? We can still make it work. So to get the mid-range, I'm just going to use parentheses. I'm going to do the smallest, the minimum, plus the biggest, the max, and I'm just going to divide this by 2. It should give us 49. Cool. So we got all of them right away, which is really nice. We can use StatCrunch the same. We can use StatCrunch the same way. A little bit faster because StatCrunch will do all of these automatically for us. I hope that's nice. So if we go to StatCrunch and I use this data, I can just type it in once and StatCrunch should do it for me. So let's go to StatCrunch. We're not going to use one of these. We're going to use an actual. We're not going to use the data. So I guess I have to go back to the book, click StatCrunch. And we're just going to open StatCrunch. And I'm just going to open it and we're just going to type it in. What is this? This is player numbers. Now, all I have to do is go to stats and make a summary, a calculator, I believe, or it's a summary stat. Nope, we don't need a calculator. I believe we need a summary stat. Okay, we need a summary stat. I put them in a column, so that's what we're going to use. We're going to use column for summary stat. Player numbers is all we have, and look, it automatically gives us the N, the mean, the standard max, the quartiles, but we can add stuff. We can add stuff like the sum if we want to take stuff away. Let's say we don't want the standard error. I could unclick that. So if I highlight these by holding shift, you can see I'm adding all of these in. Oh, it's control click. Sorry. So if I hit control click, I can get rid of certain ones like standard error. And let's also, oops, got rid of that. And let's do the sum and end the mode. Okay, cool. Now all I have to do is click compute, and here's our table. We got the mean, we got the N, we got the median, We got no mode. We got pretty much everything that we got on the other side. So that's how you do it with both programs. Whatever program you feel more comfortable with, you feel free to use. And let's just do a couple more. I did 5. I'm going to do numbers 6, 10, 13, and 18. I'll leave you the last 4. So here's number 6. And we'll use the programs now since I showed it by hand, so it goes a little bit faster. Number 6, the ages below are listed of the same 11 players using the preceding exercises. Oh, okay. How are the resulting statistics fundamentally different from the preceding exercise? Oh, these are all closer together. There's going to be a lot less variation in the numbers. So I believe here probably they wanted to say that the median was the best, and here the mean's the best because they're less spread out. So let's check out 6. And we can use StatCrunch. We can use whatever one we want. All right, so let's do another one. So these are their ages for the players. Let's drop the data in. So we have 41, 24, 30, 31, 32, 29, 25, 26, 26, 25, and 30. Notice that we do have a mode here too. We've got 2 players that are the same age. Now, I can do a move here where I go to stats and I do a summary stats for the columns. And I actually can put both in. What do I mean by putting both in? So we can actually see them related to each other. Isn't that nice? We're going to do the same set. I just have to add mode to this because there's no mode on there. And we don't need these. So I might as well, oops. Well, I guess I got to start over. And we'll just look at the ones that they like. Cool. Hit compute. The mean now is different. The mean and the median match, and there are multiple modes, but it doesn't actually give you the modes. That's annoying. What a shame. So, but we can just look at it. This is probably a place where Excel works a little better because it'll give you the modes. We have a mode of 26 and 25. But notice the differences. So that's the answer to this one. 29, 29, and the modes are 26 and 25. The mean is 29. The mode, we've got 2 at 26 and 25, and the median is also 29. The only one they don't give us is the mid-range. And the mid-range for this one is, the biggest one is 41. And the youngest person on that team was 24. So here we go. 24 plus 41 divided by 2. That's 65 cut in half. If you don't know, let the calculator do it. 32 and a half. So those are the numbers for 6. All right, let's do another one. 10, 13, and 18. So let's go to 10. All right, peas in a pot. Biologists conducted experiments to determine the deficiency of carbon dioxide in the soil affects the phenotypes of peas. Listed below, the phenotype codes were 1 is smooth yellow, 2 is smooth green, 3 is wrinkled yellow, and 4 is wrinkled green. Can the measures of center be obtained using its values? Did the results make sense? These are all, guess what? The only one we can really get is mode. Why? Because mode is what? Mode can be categorical. It could be qualitative. So we can definitely get a mode here. Figure out which one came out the most. The other, we can get the measures, but it doesn't make sense because the average would be a decimal, but like you can't have like between these colors. So we can get all the numbers. I guess I'll use Excel for this one. We can get all the numbers, but the only one we really can use is the mode. So let's put them in. So here we go. Let's put them in. 2, 1, 1, 1, 1, 1, 1, 4, 1, 2, 2, 1, 2, 3, 3, 2, 3, 1, 3, 1, 3, 1, 3, 1, sorry, 1, 3. So let's go from the 2, which was the 16th term. So it's 2, 3, 1, 3, 1, 3, 1, 3, 2, 2. So we can get the average if we want, right? We can get all the pieces that we want, but it's not gonna make sense. Equal average. Boom. 1.8, that doesn't really make sense. We can get the median. The median is 2, but that's still it still doesn't help us because that's not really what the median means because it's supposed to be qualitative. So this mean and this median are not useful at all, but the mode definitely is. So we can totally use the mode. So equal mode dot multiple. Let's see what our mode is. One. So one is the most. We can say smooth yellow is the most. That's the only thing we can say for this. So one smooth yellow came out the most frequently. It's the most common, has the highest frequency. All right, let's do 13 and 18. All right, listed below are measured amounts of caffeine drink obtained from 20 brands, 7-Up, A&W, Cherry Coke, and Tab. Are the statistics representative of the population of all cans of the same 20 brands consumed by Americans? Okay. Are the statistics representative of the population of all cans of the same 20 brands? I believe so, yes. I believe that each one of these cans for these 20 brands will be the same for all of them. So my answer is going to be yes. I'm going to find all the data, but I'm already saying yes for this. I guess we can use Excel. It doesn't really matter which one we use, right? They're all the same. So go 0, 0, 34, 34, 45, 41, 51, 55, 36, 47, 41, 0, 0, 53, 54, 38, 0, 41, 47. Did I miss one? Oh man, that's the worst. So 0, 0, 34, 34. I missed 134. All right, cool. So I just put it at the bottom. But those are all 20. So let's get the mean, the median, the mode, and the mid-range. I'm gonna say yes, I think, because one can, they're all gonna be the same. So let's start with the mean. I'm gonna do equals average. $32.55 equals median. If I could spell median. $39.5 equals mode. Oops, I'm in the wrong place. That ever happens, you can just undo it. Zero is the most. That's interesting. And remember, the mid-range is the smallest and the biggest. So if you're confused about your smallest and your biggest, we can just sort this. from smallest to largest, just make sure we just current because I've got stuff everywhere. I don't want it to move around. So it's going to be the smallest, right? So equals. If it lets me type in equals, I guess I do have to update it. The smallest plus the biggest. Okay. I like putting these in parentheses. Oh, I hit the wrong thing. Smallest plus the biggest divided by 2. But I don't have the parentheses here. It's going to divide the first one by 2 and add it, not giving me the correct answer. So if we want to add these and then divide by 2, you need the parentheses, 27.5. So those are the answers. We're going to say yes. But 18, we've got the mean of, or was that? That's 13. So the mean is 32.55. It's just these. So this would be an X bar, not the mu. The median is 39.5. The mode is 0, which is nice for our brands. And the mid-range is 27.5. All right, one more. Then you guys, I'm sure, will be able to knock out the rest. Here's 18. Okay. Below are the annual U.S. sales of vinyl records in millions. The numbers of albums sold are listed in chronological order, and the last entry represents the most recent year. Do the measures give us any information about the changing trend over time? Yes, so much more were bought. Notice that in just the last, I want to say, here's where it started the trend, right? Everything before this year. So from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 years ago. So 10 years ago. So in 2010, that's when it started changing. We can say it's because of inflation. We can say it's before anything, but this from this year to 10 years ago. So this is 2014, if this is 2024. So from 2014, vinyl sales doubled, and then it increased on a very high trajectory from then. So that's the answer to this. That's the changing trend over time. But does the measure centers give us any information about that? No. The measure centers are just, remember, for 18. Oh my God, sorry about that. So the measures of central tendency, basically, we can see in 10 years, it went up dramatically, or you can say exponentially, or you can say fully. So in the last 10 years, it went up a whole lot. But the measures of central tendency do not show that. Why doesn't it show that? Because we're just looking at the middle. We're just looking at the middle. So it's not going to show this rapid increase in the last 10 years. That's why the data, like really understanding it, the mean's not going to give us anything. We can see the trend because we have them all laid out in this order, but that doesn't help us. Okay. That's why we're going to learn about variation next. I'll probably wait to do that one because it's going to take a while. But so this will be the last one I do for today. Hopefully this stuff is useful and interesting. If it's not, sorry. I'm just trying my best to get us there. So here we go. I'll put in these numbers for this one. And this will be the last one we do. So 0.3. I'm going to start at the top. So 0.3, 0.6, and I will update this after, so I don't have that yellow thing. 0.8, 1.1. Ooh, and I already see I made a mistake. Remember that these should always have one decimal place before it. So this should be a 3.26. You could always change the number by getting rid of the decimal this way. So this should be a 3.26. I never want to give you the wrong information. So I'm not going to. And we all make mistakes, right? I'm human. So this one should be a 3.26. Only one more decimal place than what we have for them. So keep that in mind. Really keep that in mind. So for decimals, you should only have one extra place. I was just checking, make sure I didn't make any other mistakes. All right, so we got 0.3, 0.6, 0.8, 1.1, 1.1, 1.4, 1.4, 1.5, 1.2, 1.3, 1.4, 1.2, 0.9, 0.9, 1.0, 1.9, 2.5. This is where the trend gets bigger. 2.8, 3.9, 4.6, 6.1, 9.2, 11.9, 13.1, and 14.3. Let's double check, make sure we have enough. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 23, 24, 25. And we have 25. We did this correctly. So let's get the values. And because there's one decimal place, I should have my answers in two decimal places. It's always going to be one more. The first one is equal average. Now we'll do this in a different way. So equals average. I'm going to type in G1 to G25. Boom. Now, because it's giving me three decimal places, I'm going to shorten this 1, so 3.46. Let's get the median. So equals median G1 to G25. There's your median 1.4. It doesn't need to be rounded anymore. All right, now we need the mode. So it's equals mode. We're always going to do dot multiple in case there's multiple modes. G1 to G25 is also the same. Interesting. Now, finally, when I do the mid-range, to do the mid-range, I have to put this in order. So the first thing I'm going to do is actually go back to home. I need more things, so I'm going to just make this bigger. And I want to put this in order first and not expand so I don't mess with anything else. So it's going to be the smallest, which we know is equals G1 plus the biggest, which is G25, which is 14.3. And then we're just going to divide that by 2. I know it's missing stuff. Man, so it's not going to be my friend. So sometimes it yells at you and you just have to do it again. So G1 plus G25 divided by 2. And there's your answer, 7.3. So these are your three answers. I'm actually just going to copy and paste them because I'm a little tired. I did another video before this. So here we go. Ta-da. And you could always just copy and paste everything too. And then just send it to me. And I hope this was useful. If you have more questions or you need more help, just let me know, just really let me know. You've got a couple to try yourself. I'm always going to try to leave you like 3 or 4 to do yourself, just to see if you get it. But hopefully this was a good one for central tendencies. Variations where it gets harder. The formula gets tougher. It's going to be x bar minus x squared, the summation of all of that divided by n minus 1. And it really matters if you use in population or sample. So variations where it finally gets really tricky or starts getting hard. So I want to spend like a long time on that one. So good luck. Email me for questions and take care.